Right, so let's turn this off, makes it easier. Right, so if you look at the waveform now, that is how it's supposed to work. There's a little bit of extra noise there, but apart from that, it's fine. So what I'm doing is I'm measuring the two gates, the inputs to the gates, and I've got the digital input pin and the output, right? So you can see how, and I've also changed the software, so it just gives me a straight PWM effectively, but it's a trinary PWM. So this is off, this is high, this is off, this is low, this is off. Okay, and the green line, let me position center, and then I can, yeah, there we go. Well, no, actually. The green line is the output, and it should be following the input, because that's the way the circuit's designed. It's designed where the output and the input are the same, or the same logic. You know, one's an amplified version of the other. And the so the blue lines and the orange lines, right? So the blue line is the low side gate, so you should see that go high when you need a low, output low, right? And the green line is output low, so that goes high, and the output, the green output goes low. Okay, and here it corresponds there. So that's going high, and then back down to low, because it's turning on this geyser, the low side one, which pulls it down, right? Then we should see a period, right? Now the high side one, it goes low to turn it on. Okay, so that stays high until this comes up, and then it switches low to turn on the high side one, right? And we see the green line go upwards because of that's what it's doing. It's conducting it to the positive. Okay, so that one goes low, which conducts it to the positive and sends it high. So that's correct. So we should see the blue line going high here, and then the orange line going low here. And these, right, where the orange line is high and the blue line is low, is when they're both turned off, and consequently the output is central, because we've got two LEDs with a couple of resistors in there. Are they hot? No, they're not. With a couple of resistors, so it gives it something to drive against, basically, even if it's small. And if I take it out now, if I pull it out, you notice that they don't change, right? And then what I'll do is I'll plug it into the 5 volt, right? And you notice how the high side one's gone off now, right? Because it's gone high, right? Which means that there's no potential difference across it. And then if I plug it into the ground one, you see the low side one goes off. And then if I disconnect it, they both come on. Now, they both come on rather than both going off, because the circuit, when there's nothing there, that's what happens. They're both turned on, basically, when there's no output. It's not like that it's pulling both ways at the same time. You can't do that, okay? So the two LEDs being on at the same time basically means you've got no output, and they're just simply drawing current between themselves, right? And what I found is one of these guys, the BC547, one of these, I think it's that one, that's blown. It's shorting across its collector and emitter, right? And what it is that is in the let's see. And I'm guessing it's gone because so it's this one. I'm guessing it's blown because we didn't have a gate resistor in there. It's this circuit here, and it's just drawing too much to charge it. That's my guess. Okay, and so it's basically, it's keeping this turned on all the time, you see. So this one's being turned on and off, but this one's basically being turned on all the time. And even though this is going high and low on the two bases, this one's staying turned on, and this one's just, you know, well, nothing's happening there. Generally speaking, it's probably turning on and off, but because this is basically shorting, then yeah. So that was the problem, and I'm guessing it's the same with all the other circuits as well, so I'm going to have to go through them all now.